Hi everybody. In this video we're going to look at a geometric representation of distribution. So here we have a rectangle, a red rectangle, and let's see if we can figure out the area of this rectangle. You might remember that to find the area of a rectangle you just do the width times the length, or sometimes you call it the length times the height, or the base times the height, or the width times whatever you want to call it. The width times the length. So the area of the red rectangle is equal to the width of the red rectangle times the length of the red rectangle. So W here stands for width and L stands for length. Okay, so the width of the rectangle is 4 units, whatever the units are, centimeters, inches, whatever they are. It's 4. Okay, times the length of the rectangle is from here to here. Now from here to here is 7 units, and from here to here is 3 units. So from here all the way to here must be 7 plus 3 units, which of course is 10 units, but I'm just going to write it as 7 plus 3. Okay, so, and we could evaluate that. You could probably do that in your head, but I'm just going to leave it this way for now. So the area of the red rectangle is equal to 4 times 7 plus 3, with that being in parentheses there. Okay, now there is actually another way that we could have figured out the area of this rectangle. The area really means the space inside of it, okay? The other way that we could have done that is by breaking it up into 2 smaller rectangles. So I'll do the best I can of drawing straight lines here. It's not very good. Okay, so let's say I want to break this big red rectangle up into a green rectangle and a pink rectangle. Okay, so the area of the red rectangle should be equal to the area of the green rectangle plus the area of the pink rectangle. And that's what I put right over here. So you see the area of the red rectangle is equal to the area of the green rectangle plus the area of the pink rectangle. Now to find the area of the green rectangle, we need to do the width of the green rectangle times the length of the green rectangle. So the width of the green rectangle is 4 and the length of the green rectangle is 7. So that would be 4 times 7 to get us the area of the green rectangle. And we need to add the area of the pink rectangle. And to find the area of the pink rectangle, we need the width of the pink rectangle times the length of the pink rectangle. So the width of the pink rectangle is actually the same as the width of the green rectangle, and that's 4 units. And we have to multiply that by the length of the pink rectangle, which is 3 units. Okay, so another way that we can calculate the area of the red rectangle is what we just did over here, 4 times 7 plus 4 times 3. Now, let's pause here for a second, and let's just realize that both of these expressions refer to the exact same thing. Both of them refer to the area of the red rectangle, which you can't see now, but what we had in the beginning, which looked like that. Okay, this represents the area of the red rectangle, and this also represents the area of the red rectangle. We just found it in a different way. But that means that this must be the same thing as they must be equal to each other because they both represent the same thing. So I'm just going to write it again here. 4 times 7 plus 3 must be equal to 4 times 7 plus 4 times 3. Okay, and we know that they must be equal to each other because, again, they both represent the area of the red rectangle. They both represent the exact same thing. And this is an example of distribution right here, where we can see that if we draw arrows here, we're distributing the 4 over the 7 and the 3. Okay, and that is, so 4 times 7 plus 3 is equal to 4 times 7, which we have over here, plus 4 times 3, which we have right over here. Okay, so basically whenever you want to distribute something, you just take this number out front and you multiply it with the terms on the inside. And in this case, we're just adding everything up here. In another video later on, we're going to see what happens when we have some negative numbers or some subtraction. But here we would just be adding them up. So let me do one more example. Over here. And now I have sort of a, let me get this on the next page. Now I have a whole page to work with. Okay, so now we have a larger rectangle, but again, we're going to calculate the area of this rectangle in 2 different ways. First of all, which rectangle am I talking about here? I'm talking about this rectangle. Okay, I'm not doing such a great job of drawing over it, but hopefully you get the idea. Okay, what if I wanted to find the area of this red rectangle? Well, again, what I can do is I can multiply the width by the length. Now, the width in this case would be 5 plus 3, which of course you know is 8, but I'm just going to write it as 5 plus 3. So I take that width and I multiply it by the length here, which would be 2 plus 6 plus 4, which is 12, but I'm just going to write it as 2 plus 6 plus 4. Okay, now, so if I were to evaluate this, that would give me the area of the red rectangle. Now, is there another way I can calculate the area of the red rectangle? Yeah, I can break it up into all of these smaller rectangles that you see over here, and then I would just have to calculate the area of each of these and then add them all up. Okay, so to get the area of this one over here, the width is 5, the length is 2, so that would be 5 times 2. Okay, I'll write that over here, 5 times 2. And then for this one, it would be, the width again would be 5. Okay, the width of this is the same as the width of this. And then the length is 6, so this would be 5 times 6. Let me do the other ones quickly. Here the width is 5, the length is 4, so 5 times 4, or 20 square units, that would be the area of this rectangle here. This one would be 3 times 4. The area of this one would be 3 times 6. Okay, the width is 3, the length is 6, and the area of this one would be 3 times 2. Okay, the width is 3, the length is 2. Okay, so if we add all of these areas up, it gives us the area of the full rectangle, which I outlined in red here. So let me just do all of this. I'm just copying everything that I put over here in here. I hope I don't run out of space. I am running out of space on the Word document, but I can cheat and I can keep writing. The Word document's not going to know. Okay, so again, this is the width of the red rectangle and times the length of the red rectangle. And this is the area of all the smaller rectangles added together, which also is another way of finding the area of the big red rectangle. So both of these things describe the area of the red rectangle, so they must be equal to each other. And we can see here, this is another example of distribution. And notice that what we have here is just every combination of these numbers together with these numbers. So for example, we have 5 times 2, that's over here. 5 times 6, that's over here. 5 times 4, that's over here. And we also have, I'll just do it over here. 3 times 2, that's this one. 3 times 6, that's this one. 3 times 4, that's this one over here. Okay, so all of these are just every combination that we could make of these numbers together with these numbers. And it makes sense when you look back at the picture over here. We had this 5. To figure out the areas of these 3 rectangles over here, we had to do 5 times 2, 5 times 6, and 5 times 4. To figure out the area of these 3 rectangles here, we had to do 3 times 2, 3 times 6, 3 times 4. Okay, that gave us these over here. So hopefully it should make sense how we got these numbers and why this is really just every combination of these numbers. And here's something very important, though. I hope you're still paying attention. I know I've been talking for a while. Something very important that you probably noticed, but maybe didn't think too much about it, is that these 2 numbers are not getting multiplied together, right? I don't have a 5 times 3 anywhere in here. I didn't have to, none of these areas are 5 times 3, right? And likewise, the 2 and the 6 and the 4, they do not get multiplied together. So these numbers do not get multiplied together, and these numbers do not get multiplied together. But these numbers get multiplied with these numbers. Okay, so it's a very common mistake when students are doing distribution to multiply these numbers together and maybe to do some combination, multiply some of these numbers together. But if the numbers are in the same pair of parentheses, like the 2 and the 6 and the 4 are in the same parentheses, then they don't get multiplied together. And the 5 and the 3 are in the same parentheses, they don't get multiplied together. You have to multiply these with these, okay? And you do actually get the same answer. This really does turn out to be the same as this. So for example, I forgot to go through it in the last example, but you know what, let me just do it now. Sure. So 5 plus 3 is 8, right? And 2 plus 6 plus 4 is 12. Okay, and then 8 times 12 is 96. Right, so I get 96 over here when I add these up and then multiply them together. What if I do it this way? 5 times 2 is 10, plus 5 times 6 is 30, plus 5 times 4 is 20, plus 3 times 2 is 6, plus 3 times 6 is 18, plus 3 times 4 is 12. And let's see, everything is getting added here. So I'm allowed to add the numbers in any order that I want because addition is commutative. So let me just add it in the easiest way possible. I see, let's see, 18 plus 12, that'll give me a 30. And then I have 10 plus 30 is 40, plus 20 is 60, plus 30 is 90, plus 6 is 96. So all of this is equal to 96. So you see that this really is, when you do make these combinations and you just lay it all out here, then what you get over here is in fact equal to what you have over here. Okay? All right. So I'm going to end the video there and have a great day.